Hello everyone. In the previous session we talked about indexes, seek and scan operations. Now let's learn how SQL Server decides which indexes to use and what operators to perform for specific queries. First of all, when you have heap table, SQL Server uses only table scan to retrieve data. SQL Server cannot use another operator like index seek, index scan. For example, we just create heap table without any indexes and run just simple select query. You can see table scan here. No other operation can be used to access data. Now, suppose we created clustered index on this heap table. In this case, SQL Server has several options to retrieve data. Table scan, non-clustered index seek with RID lookup, non-clustered index seek, non-clustered index scan. So, how SQL Server makes decision now? First of all, SQL Server looks at estimated cost with each operation. It will choose the operators which are expected to give the lowest total estimated cost. This estimated cost is defined by the sum of estimated CPU and I/O processing costs. So, how SQL Server calculates this estimated CPU and I/O processing cost? It is based on the estimated number of rows retrieved by the query. And finally, this estimated number of rows are calculated based on the statistics. So, we should first understand how these statistics are calculated first. This is a starting point. Let's first learn how to check what statistics are available for specific table in SQL Server. For this, we use this query. Here we can see only one statistics. These statistics were created automatically for business entity column when we run this statement because business entity ID is in very close here. Statistics are created column level and can be multi-column or single column statistics. Statistics are created in three ways. Automatically by the query optimizer when auto create statistics on and when you run create index. And secondly, automatically by the query optimizer when auto create statistics on and query uses very close. And finally, you can also create it manually by running simply create statistics statement. Let's now create non-clustered index and see how statistics are created automatically. You can see the properties of table here and confirm that auto create statistics are on, which means statistics can be created automatically. Now we have statistics with the same name of index. Let's see properties of the statistics by using dbcc command. Every statistics consists of three parts in SQL Server. In the first part, we can see name and update or creation date of the statistics. Rows here is the number of rows that existed in the table when the statistics object was created or last updated. Row samples is the number of rows that were sampled when statistics object was created or last updated. As you can see, statistics was created by using all the rows in our column, which is full sample, right? So, if statistics are created automatically, Query Optimizer determines a statistically significant sample by default. Okay, you don't need to specify. You don't need to do anything. Of course, you can also set sample size if you create statistics by yourself. The second is density information. This is equal to 1 divided by number of distinct values. We can easily run this command to come to the same output. SQL Server uses this density information to estimate the number of unique values in the given column. When do we need number of unique values? Of course, by using group by operation. Therefore, this density information is very much useful when query has group by operation. And next, third one is histogram. Histogram is created for this target column, which is first name in our case. It contains partitioning histogram steps. Here we have 200 steps. Range high key is the upper boundary of a histogram step. The value A is the upper boundary for the first step shown, while Aaron is the upper boundary for the second step shown. This means the second step contains values between A dot and Aaron. Range rows is the number of rows contained within this range. As you can see, between A dot and Aaron, there is only one row. Let's see which row it is. Okay, it is this row. Eq rows is the estimated number of rows whose column value equals range high key. For example, here there's only this number of rows of A dot. This can be confirmed by looking at this table. Distinct range rows is an estimated number of rows with distinct column value inside this range. Average range rows is the average number of rows per distinct value, excluding the upper boundary, and it is simply calculated as range rows divided by distinct range rows. Now, let's see how histogram is used. Let's run this simple query. Here, table scan is used because we are not specifying any predicate in where clause. There is no where clause right here. In this case, estimated number of rows to be read simply becomes equal to the number of rows in the table. In this case, SQL Server does not use any statistics. It's very much simple to estimate the number of rows read, right? So next, let's run this query. Here, if we look at estimated number of rows, we can see it is 2. Where it is coming from? This number is coming from statistics histogram column, eq rows column, right? Here, if SQL Server do scanning operation, it should process this number of rows. If it does seek operation, it processes only these 2 rows. Okay, so statistics are used in this way to decide whether to use scan or seek. Therefore, SQL Server chooses seek operation here because bringing 2 rows is much less costly than scanning the whole table. Let's choose only first name here so that SQL Server does not do RID lookup. Here, in the same way, estimated number of rows read is calculated, which is equal to 2. Finally, let's look at index scan. If we run this, we can come to index scan. Why index scan is being used? In this case, we are bringing all the rows, which means estimated number of rows is equal to all the rows in the table, right? In this case, scanning is less costly as there is more cost bringing the number of rows with index operation. Index seek has its own index operation cost. Therefore, we should take also that account. And here, scanning is much better. Now, I hope you understood how important it is to correctly estimate the number of rows, and we should have very much correct statistics. Otherwise, incorrect plan with incorrect operators might be selected. You should be always careful with these problems with statistics, which might lead to performance issue. First is missing index. If there is no index, SQL Server cannot estimate the number of rows correctly, leading to incorrect execution plan. Next one is out-of-date statistics. Your data might have changed already, making statistics out of date. In this case, SQL Server generates and chooses operators based on incorrect statistics. This can lead to, of course, performance degradation. Let's finish this session with clustered index case also. It's nearly the same with non-clustered index case, but table scan never happens in this case as heap table changes to clustered index table. In the case of clustered index also, statistics and correctly estimating estimated number of rows is very much important. Let me show you a few examples, of course. In the first case, as we are not using predicate, clustered index is being used. In the second case, as estimated number of rows is equal to 1, which is of course coming from statistics, SQL Server is choosing seek rather than scan. I hope you are now more comfortable with scan and seek operations and also understood how important statistics are. Happy learning!